Hello teachers! Have you ever noticed your students struggling with the concepts of perimeter, area and volume? These fundamental aspects of geometry can sometimes be challenging for students to grasp. When we introduce volume, it takes students into the third dimension, measuring the space an object occupies. This leap from two dimensions to flat surfaces to the third dimension of depth can be challenging, as it requires students to think in new ways about space and measurement. Concepts like volume introduce a whole new dimension, which leads to students having several misconceptions related to it. In this video, we'll analyze the common mistakes that arise when students calculate the volume of cubes and cuboids. We will also try to identify these stumbling blocks and explore strategies to guide students towards an accurate understanding of volume. Mr. Kumar, a middle school math teacher at my school, is also facing similar issues. Let's learn more about this. Good morning, Mr. Kumar. What happened? You look worried.
Good morning, Saraswati ma'am. I've been reviewing the answer sheets of my grade 8 students and I'm surprised to see that many of them answered the question incorrectly. I'm concerned that my students' responses were very similar to those from other schools.
What do you mean, Mr. Kumar?
The question I asked was the same question used in a survey to check understanding levels of students around the concept of volumes using unit cubes. See, here is the question. This is the survey data. As you can see, most students got it wrong. And my students' data is quite similar to this. I am extremely sad and now beginning to question my lesson plans and teaching style. Why could I not teach the concept correctly to my students?
Absolutely not, Mr. Kumar. Let's analyze the answers given by students and get to the root cause of the problem. Highest number of students think that the volume of a 3D object is composed of total number of visible unit cubes, and hence they might only count the cubes they can see.
That explains why maximum students who got it wrong. They may have selected 11 cubic centimeter as they would have also simply counted the visible cubes and assumed it to be the volume of the shape. Students who chose 12 cubic centimeter were the ones who got to this answer by calculating the perimeter of the base instead of calculating the volume. They might have added the sides, thinking they were solving for volume. 4 centimeter plus 4 centimeter plus 2 centimeter plus 2 centimeter counts to 12 centimeter.
These students could not understand what volume is, and from their prior understanding of perimeter of a rectangular surface, calculated perimeter of the base. The students' difficulty in understanding volume and their reliance on calculating the perimeter of the base may be linked to how their brains are conditioned through prior learning experiences. When students have a strong memory of a familiar concept like perimeter, they may default to using that approach because it's more ingrained in their memory. This underscores the importance of reinforcing the distinctiveness of new concepts like volume in this case, ensuring that students can differentiate it from previously learned concepts like perimeter.
Yes, that might be true.
Sir, I tried the same with this cube. Many students calculated the answer as 40 unit cubes. It is clear that students mistakenly added the surface cubes to find the volume, as 16 unit cubes plus 12 unit cubes plus 12 unit cubes is equal to 40 unit cubes. They were not able to visualize the interior of the shape, which prevented them from accurately understanding its volume.
Thank you, Saraswati ma'am. Now I think I get the reasons for so many of my students getting the answer wrong. All of these misconceptions stem from the fact that students find it challenging to imagine how the smaller cubes combine to form a bigger one. Now that we know the problem, ma'am, I think we can solve it by introducing the volume concept with the unit cubes.
Not just the unit cube, we could use this simple checklist to help the students find the volume of any cube or cuboid solid shape. Let me show you with an example. Compose simple shapes with unit cubes to make the students visualize how a composite solid is made as per the checklist. Ask the students the first question. How many small cubes is the large solid made of? And have the students count the number of unit cubes in each shape by decomposing the shape. Next, ask the students what is the volume of one of the small cubes, and ask the students to note that down. And finally, ask students what is the volume of the large solid, for which they can multiply the volume of one small cube with the number of cubes in the shape to arrive at the volume of the shape in cubic centimeter.
This is a brilliant idea, ma'am. I think post using simple steps, we can gradually transition the students to shapes of medium difficulty like this and use the checklist you mentioned to make them feel confident in now calculating the volume for these shapes too.
Teachers, I urge you that you too must try this activity in your class to help students see the number of unit cubes used to build a shape, thus making them understand the concept of volume and visualizing the structure of the shape. Talk to them about the different ways in which they can decompose the solid into smaller chunks and calculate the volume. Once your students are comfortable with basic concept, ask them to find one more way to reach to the solution. That is what is called flexibility and development of mathematical thinking. And once students can confidently count and calculate using unit cubes, we can introduce the formula for volume by multiplying length, breadth, and height. Explain to students that the formula for volume is a shortcut derived from their understanding of unit cubes and how dimensions multiply to represent the total space a solid occupies. To build true fluency, scaffold learning by using concrete materials and pictures alongside formulas, gradually reducing support as students gain confidence. Let's empower our students to think beyond numbers and formulas to truly grasp the essence of mathematical concepts. If you also found this short video insightful, please like, share to stay updated with more teaching tips and strategies.